of beautiful subarrays. So first, a subarray is a continuous part of a array. So suppose if this is the array 43124, here 43 or 431 or 31, like any continuous part, any continuous chunk is called as a subarray. Now, what is a beautiful subarray? So here, a beautiful subarray is stated that we can choose any two indexes like I and j, where I must be less than j and j must be less than nums of length. And we have to choose k, a bit k, such that in the binary representation of those both numbers, um, the present bit is set. So suppose if it is the number is 1 and 3. For the number 1, the binary representation will be 0, 1, and whereas for 3, the binary representation will be 1, 1. So in both these numbers, the bit 0 is set. The LSB or the leftmost bit is set. This bit. We can select any binary number, any bit, such that both the bits in that numbers are set, and we can subtract 2 to the power of k from that. So in this example, if we have taken 1, here in both the bits, 1 is set, and since 1 is set, we can subtract 2 to the power of 1. That means we can subtract 2 from both the numbers. Also, we have to find that how many number of beautiful subarrays are present, uh, which concludes that how much continuous parts are present, where if we have taken any bit k and we have done this process for any number of times, the final result must be 0. Uh, suppose if there is a subarray as 1, 2, and 3. So first we have selected bit, their binary representations would be 0, 1, 1, 0, and 1, 1. So for the index, we are first considering the 0th element and the second element. And the bit we are considering would be 1. Um, if we consider first bit and we have subtracted 2 from here and here, 2 from the both numbers, we would we would we can the final result would be equal to 0. So we have to find the supplement. So what I have done is that um, the only uh, the only time when the actual subarray becomes 0 is at every position there are even number. Like if at one index here there are even number of times the one bit is set, and same with the 0th bit. The 0th bit is set for even number of times. So if any particular position the bit is set for even number of times, we can make the number as 0. So the two possible ways are either same number is repeated even number of times, or the numbers are present 2 to the power of n minus 1 times. Suppose 1, 2, 3, or uh, here 2 to the power of here 2 to the power of 2 is 4, minus 1 is 3, so 1, 2, 3 are present, or else 1, 2, 3, 4, 5, 6, 7. Even here 2 to the power of 3 is 8, and minus 1, 7 number are present. So this is the condition. So what we can do is that we can use bitwise XOR operation to find the array, how many times it has a beautiful subarray. So first we can declare IU code in Python. So we declare a dictionary, and we can take a variable as x, which is equal to 0, And while iterating through this array, um, we can do x equal to x XOR the element in this index. When we do the XOR, um, if so when we can say that it became 0, suppose here the XOR is 4, and after some time again it became 4. So the between part between these both indexes has become 0. Or if it started with some number n, and after some time it became 0. These are the two cases where we can consider that the subarray between the part has become 0. So while iterating, if we have taken this XOR value into the dictionary, and after some time again this value repeated. So it is already present and it has again repeated. That means the part in between these two fours has become 0. So that
Anil,
subarray.
can we take some example and like trace it,
Yeah.
these
Uh,
two
sup-
cases which you are saying?
uh, Suppose the numbers are 1, 2, and 3. XOR value. Suppose the XOR values are 4, 1, 2, 3, and again 4. So here the XOR value is 4, and after this XOR 1, XOR 2, XOR 3, we get 0. So that's why again we are getting 4 back. Uh, or else there is a subarray as 1, 2, 3. So if we have done XOR of this subarray, we would get as 0 the XOR value after this point.
Okay, so basically for 1 to 3 we are starting at 0, and
Yeah,
0 XOR 1 will become 1, then 1 XOR 2 will become 3, and 3 XOR 3 will become 0. So
0.
we
Yeah.
started at 0 and ended up 0,
And
so
that
we can
is,
say that, yeah,
yeah.
got
Uh, so these are the two conditions when we can say that the subarray present between those two indexes is 0, has become 0. That means it contains all the bits all the bits which set in a even number of times. Um, so the count would number of subarrays would be, uh, suppose if there are three zeros present. So how many number of beautiful subarrays can be formed by this? Uh, this is
it.
one beautiful subarray which can be formed. Like uh, I'm indexing them as 0, 1, and 2. So, so the beautiful subarrays can be formed will be of either index 0 or index 1 or 2, or 0 and 1, or 1 and 2, or 0, 1, and 2. So if the XOR becomes 0, so there will be these many number of possibilities. So if it is not 0 and it is a number, suppose a number is there like 4, after that it is 1, some numbers 1, 2, 3, again 4, and after that there are some numbers like 1, 2, 3, 4, 5, 6, 7, and again 4. So here the XOR, so the number of times it is a beautiful subarray is that if we index them, so one subarray which can be formed is that starting at index 0 till index 4. That can be one subarray, 0, comma 4. And another subarray can be formed is starting at index 4 till index 12. So it can be 4 comma 12, and another can be formed. We are taking entire subarray. So here we have started all this subarray we have taken into consideration, and again it became 4. So the part in between that is 0. So one more is 0 and 12. So 3. This is the number of times. This is the number of beautiful subarrays present in this array. Is that clear?
There is one more subarray also, right? From index 4 to index 8.
5 to 8.
Fine.
Or 5 to
Yeah.
7. 4
5
to
to
8
7.
also, yeah.
Yes.
5 to 7 also,
4
4
to
to
8
8
also, and
also.
5 to
Yes.
7 also.
Yeah. If the XOR value is again repeated, then even that would be considered.
Yeah.
So what I have done is, like, I have started iterating through the array, and I have taken a variable x, and I have done XOR with that x to every element. And if that x is already present in the dictionary, it is already present. So we have already come across that number, and if we have already come across that number, so I would I would make my count as C plus equals to previous count of that, and I would increment the present value count. Else, I would make the appearance of that element as one. If we take an example, like same this 4, 1, 2, 3, 4.
Uh,
So now, yeah, yeah,
yeah. Anand, if I understand your approach correctly, you're eventually coming up with a uh, prefix XOR for every value, and then you are considering the count to count total arrays, right?
yes.
Yeah, there are some beginners also in this call. If I ask you from their side, like what made you kind of conclude that XOR will work and prefix XOR
Uh,
will work for this problem?
so here it is given that we have to make the subarray as 0,
Hmm?
and what we can take is that we can take any two bits. If they are 1 in that both numbers, then we can actually subtract. So taking this example, since XOR of so here it is 4, and
No,
again
see,
the 4 has a
you are using the word XOR, but my question to
yeah.
you is problem nowhere mentioned XOR. How did idea of XOR of subarray come to the mind?
Uh, we can make it 0 only in two conditions, like either if same number is repeated for even number of times, or um, all the numbers till 2 to the power of any number n minus 1 is present. So to find that, suppose a number is present even number of times. Suppose 1 is present even number of times. How can we find that? We can find that if we XOR that, our answer would be 0 if any number is present even number of times.
Mhm.
Or else the same as this. Um, if we take 1 to 2 to the power of n minus 1, and we have XORed all the numbers, we would
Mhm.
again get 0. So by this, I have thought that we can use XOR.
No, but if array had 1, 8, and 9, if array had 1, 8, and 9,
So 0, 1. Is it VS Code visible?
no, you shared only browser, not the entire
Okay.
screen.
One second. Uh,
So if number is 1, 8, and 9, then 1 in binary form will be 0001. 8 will be 1 000, 0001, 1 000, Yeah, and 9 will be 1001. Now
Uh,
they are neither consecutive and nor same. 1, 8,
uh,
and 9. But XOR is still 0.
so first, we can take bit as 0, 1, 2, 3. We can take third bit, and we can third bit of these both elements is 1. So we can subtract 2 to the power of 3 for both numbers.
Yeah.
And here also the both numbers are set, so we can take 2 to the power of 0 and we can subtract them. And the final result after subtraction would be still 0.
Yeah. Yeah, but I think I got your approach, what you are pointing towards. Yeah, and yeah, Anand, this has been your first editorial session. I really appreciate you for coming forward and taking this up. Uh, so thank you so much, Anand, for doing this. And
Thank
yeah, this I want to share with others also. If anybody feels like they would want to come and share the knowledge in this session, this is kind of a session where people get an opportunity to express themselves to others and discuss their approaches, their solutions. And at the same time, it is also equally important that people who are attending the session also benefit and understand the approach. So yeah, thanks, Anand, for that.